My name is Almar Klein. I'm a freelance software engineer working most of my time with continuum analytics. And today I will be talking about running Python in the browser. So I think it's evident that the web is getting more important in many areas of our lives, including how we publish scientific results. Especially in the last few years, we got HTML5 and JavaScript has much improved, so we can make our visualizations and our applications much more interactive. And that means that we can create a much richer experience for our end users. And this is a good thing because this means that we can in some cases convey our ideas more effectively, and we can let our users explore the data in novel and interesting ways. So this is something that we should embrace. There is, however, one problem, and that is that the language of the web is JavaScript, and JavaScript kind of sucks. I think that anyone who has done some programming in both Python and JavaScript can relate to these photographs. If you program in Python, everything makes sense and you become happy, and most parts of the language have been well designed. And this is much less the case in JavaScript. It's especially for Python programmers, this contrast is pretty big, much higher than, for instance, for a programmer who programs in PHP. And I think this is the main reason why there are so many projects that try to bring Python to the browser in one way or another. So in order to give sort of an overview of these different projects and to understand how they relate and how they differ, I categorize them, or I group them in three categories. Projects that are transpilers, projects that are basically an interpreter written in JavaScript, and compiled interpreters. So in a transpiler, you would start with Python code offline, and you would transpile that to another something that can be executed in the browser. Most often it will just be JavaScript. One example is a rapid script, which is a pre-compiler for JavaScript, similar to CoffeeScript. And PyScript is a project that I've been working on and will be telling you more about in the second half of this talk. And it takes Python code, transpiles it to JavaScript, but it's implemented in Python, which makes that you can, for instance, write a Python module, but write a couple of functions in this same Python modules, but these will then be executed in the client instead of in Python. So it's suited for a more Pythonic workflow. The advantage of this group of projects that transpile Python code to JavaScript is that you're basically really writing JavaScript using a Python syntax. The advantage of that is that it's pretty fast because an integer will just be a JavaScript number and a string will be a JavaScript string. So things are faster. But of course, it's also a disadvantage to some extent because it's not as Pythonic as it could be. In the category that are JavaScript-based interpreters, these are projects that basically have an interpreter, a Python interpreter written in JavaScript. And the two most well-known projects that do this are Sculpt and Brighton. Sculpt is more aimed at being used for educational purposes, so letting people online learn Python by writing code in the browser. And Brighton is intended to be used as a substitute for JavaScript to develop web applications. In this case, this is more real Python in that a Python integer behaves much more like a Python integer and not a JavaScript number. And a string is really more like a Python string, which is, on one end, it's a good thing because it's more genuine Python, but because you have boxing, it's also much slower. So these projects are typically 100 times slower than the CPython interpreter. Also, it takes a little bit more memory to get them loaded as a library. And the third category are the compiled interpreters. The most well-known example is PyPy.js, which basically is a project where they took the PyPy source code. So PyPy is an interpreter, a Python interpreter implemented in a slightly different way using a JIT. and it runs much faster than regular C Python. And they took that source code and they compiled it to a sort of subset of JavaScript using the LLVM toolchain and Emscripten. And the advantage of this is that they didn't have to write a lot of code, so it should be relatively easy to maintain. They took a project that already existed and make that work in the browser. And for instance, a few months ago, there was a new version of PyPy that was much faster, and they just had to recompile things, and then their project is faster as well. So this solution is actually faster than C Python. There's also a technology called Pinnacle, which stands for Portable Native Client, which is a Google solution, so it's only for Chrome. And some people have demonstrated that they can actually run Python plus NumPy in the browser using that technique. However, it's Chrome only, so probably it's not something that we'll see a lot of in the future, I would say. But there is some exciting other developments going on, namely WebAssembly. So WebAssembly is a standard that people are working on for executing native code in the browser. And this is something that will be adopted by all the big browsers. And I expect that when that becomes available, there will definitely be people implementing a Python interpreter using that approach. So the advantage of this approach is that it's real Python and it's fast. But the disadvantage, or the main disadvantage, I guess, is that it's quite large. At least in PyPy.js, for instance, the virtual machine alone is over 13 megabytes. So it's not something that you would easily embed in your visualization. Then there is like a fourth category, maybe, that of frameworks. So, and these are mostly based on top of a transpiler. And the most well-known one is the PyJS project, formerly known as Pajamas. And this was one of the first projects that try to bring Python to the browser. So they have basically paved the way for other projects to do the same by at least demonstrating that this is something that is possible. It is, however, a project that is a bit older, and it has some technical depth. For instance, they use browser detection, and then they have a different JavaScript code, exported JavaScript code for each browser. And that's not something that you would do nowadays, I guess. Flex is a project that PyScript, the project that I'm talking about more, is basically a part of, and I'll also mention it later in this talk. So we have these three categories, and we can compare them using different measures. For instance, how Pythonic is such an approach. Well, I already mentioned this along the way to some extent. If you have like this compiled interpreter, this is something that's genuinely Python. The JavaScript-based interpreters will be sort of quite Pythonic, but there are, at least in the current implementations, they don't have all the features that C Python has, so they are not complete in that sense. And the transpiler is, in this group, the least Pythonic in that it's not really Python, but really JavaScript that is made a lot more Pythonic. In terms of speed, the compiled interpreter is definitely the fastest, and the JavaScript-based interpreter are much, much slower. And the transpiler sits somewhere in between. Depending on how much extra niceties or how Pythonic the transpiler is made, the speed might be compatible or comparable with the compiled interpreter because it's JavaScript, and so it should be quite fast. But there is some overhead. For instance, if you want to make operators behave the same way in Python as in this transpiled language, you have some overhead, and that will add up and make things slower. In terms of size, the transpiler projects basically have very little extra size. Of course, they generate JavaScript that takes a bit more lines of code than if you would write it yourself. But other than that, there's nothing extra that you need. And in JavaScript interpreters, like category B, it's about 1 megabyte to a couple of megabytes that you have to load as a library. which is, depending on the situation, you might consider it as a heavy solution or a light solution. So it depends on what you want to do with it. And the compiled interpreters are, are heavier, and this also, again, this might be acceptable, it might be not. So I think if you want to run Python in a browser, it's not enough to say, I just want to Python in a browser. You have to be more specific. You have to ask yourself, what do you want? And it depends on the use case. So if you want to run the SciPy stack in the browser, the only way to go would be to use a compiled interpreter like PyPy.js, simply because there's no NumPy in JavaScript. If you want to write Python in a browser for educational purposes, so have a website where people can write some code and run it just to learn it, then the category B, so the JavaScript interpreters, the Python interpreters written in JavaScript, make a lot of sense because they're quite lightweight and they work. However, if you want to write web applications in Python, I think that the main way to go is using a transpiler-based approach. Even though, for instance, Brighton was designed to be used for creating web applications, the fact that it's so slow, I think it will prevent it from being widely adopted. And similarly, a compiled interpreter could, in theory, be used to create web applications, but it's so huge. You have to wait a couple of seconds before you can even start showing something, because you have to, load 13 megabytes of virtual machine. And then there is another use case where you want to define client-side interactivity in Python. For instance, you have written you've done some analysis on some data, and you're exporting that to a visualization using some sliders, and you want to define what happens when the user manipulates a slider. I will demonstrate some of that later on, and that is something I think that transpiler-based approaches would be very good about. Okay, a little bit more about PyScript. So this is a transpiler-based approach. If you want to try it out, you can install it using pip or conda. And basically, there's one command that you want to import. By the way, it's part of Flex, part of the Flex project. But if you import it in this way, only the PyScript transpiler is loaded. And this is the main function, and you can give it either a string with Python code, or a function object, or a class, and it will give you the corresponding JavaScript code. So the API is is very simple. So if you want to play with it, it's easy. Again, I already mentioned this to some extent. Python is just JavaScript, and that you're really just writing JavaScript, but it looks like Python. So a list is really a JavaScript array, a dictionary is a JavaScript object, and floats and ints are just JavaScript numbers. And this is good in some ways because it makes things much faster. However, to make things more Pythonic, all the building functions of Python are supported, as well as all the methods of the list, string, and dict. So you can do all your string manipulation as you're used to. You can manipulate your list and dictionaries as you're used to. So writing in PyScript looks a lot like Python. Also, there are some JavaScript quirks. So especially if you know JavaScript, you know that there are some issues, and these are fixed in PyScript. For instance, isInstance just works as you expect it to be. Empty list and dictionary evaluate to false, and you can do deep comparisons. So these are things that are not the case if you just use JavaScript. However, and this is, I guess, the big advantage of any transpiler-based project, sometimes the JavaScript shines through. And in some cases, this is not very, not necessarily that bad, quite harmless. But it can be annoying or unexpected, especially if you're not used to JavaScript, or if you just, if it's not something that you keep in mind. So we're actually using PyScript in a couple of projects, so I want to demonstrate these quickly. The first one is in Bokeh. As most of you will know, Bokeh is a plotting library being developed by Continuum Analytics. And one thing that already was possible for quite a while is that you can define, maybe I should use this thing, you can define client-side callbacks. So this is a small visualization. Whoa. This is a visualization with a plot and some sliders. And when the sliders are manipulated, this piece of JavaScript that we provide here in this way using a multi-line string will get executed in the browser to update the figure. And this is something that already existed. And a couple of weeks ago, we have made it possible to also write it in this way. So you just define a callback in Python, and this callback is transpiled on the go and embedded in the final plot, basically, and it's being executed when the slider is manipulated. Right. So, short demonstration. Oh. So you can manipulate the sliders, and the code that does this updating of the plot is the code that we wrote in Python. Another application where PyScript is used is the Flex project. So actually Flex is the project that started this, and we needed transpilation, and PyScript is sort of a sub-project that came out of that. And Flex is sort of a GUI toolkit that uses web technology for its rendering, but you can similarly look at it as a server for hosting web applications. Again, a short example. So in Flex, there's this notion where we have objects that have a representation both in Python and in JavaScript. And these objects are automatically synchronized, and events are transparently sent between Python and JavaScript. And this little bit of code shows the implementation for the button widget. And well, the interesting part of it is that you have one class in which you define the Python behavior of these objects, as well as the JavaScript behavior of this object, by writing it out in Python. So these individual functions here are transpiled and then compiled together to create a Python class that is then used to create the widgets. So a small example. So this is some weather data, and we have some sliders here, and we can manipulate them and update the plot. And this behavior of when the sliders are manipulated and the plot gets updated is again something that is implemented in using PyScript. So the advantage of this is that users can very easily define client-side interactivity without having to learn JavaScript. So the threshold to be able to do such sort of things is much lower than if users would have to write JavaScript for that. And the final use case that I want to mention is a project together with Clinical Graphics, a company here in the Netherlands. And we are developing a web application for annotating medical images. And we use a similar approach as we do in Flex, where we have written most of the code, well, actually all of the code in PyScript, just scrolling through one of the implementations where we see here an undo stack. And this is a contour tool, so a tool to manipulate. I cannot really show all the code, but you see here that there is an event. I'm terrible at scrolling without a mouse. So we have an on-mouse event method that we implement. So events get in here, this gets executed in the client, and we take the appropriate actions. So to demonstrate this, where is it? Right. And now I have to try and scroll in, zoom in. So this is the web application that we've built without writing a line of JavaScript. And you can manipulate the contour, and I don't have time to to discuss exactly what the reasoning about this, but you can see how this works, more or less. Okay, in summary, I think that we will see a lot more projects that use Python in the browser over the years, especially when we get WebAssembly. There should be some interesting things that we should be we go seeing then. Also, it's not that there is like one solution that brings Python to the browser and serves all use cases. It's also not something that we will have for the coming time, because there's different approaches that you can do that, and each of these categories that I mentioned has their own use cases that they solve. Yeah, that's it. Thank you for your attention.
We have time for questions. Are there any questions about JavaScript, but Python instead?
Is there any performance loss if you were to use what you're describing here?
You mean compared to writing it in JavaScript?
Yeah, in pure JavaScript?
Yeah, sure. So, well, I already mentioned if you use one of the interpreters written in JavaScript, these are much slower, like 100 times slower than CPython. And for the transpiler-based approaches, there's this big compromise that you have, because you want to make things very Pythonic, but in order to do that, for instance, if you want to make sure that you can multiply a string with a number, right? In Python, then you repeat the string. To make that possible with a transpiler, you would have to overload the times operator. That means that everywhere in the code where there's a multiplication, there is a function called extra, and that adds overhead. And the more of these Pythonic features you provide, the more overhead you create. And that is something that I'm still struggling with, and also discussing with some developers of similar projects. One solution might be to create like a pragmas or sort of context in which you turn these features off, so that well, whatever I do within this, I won't have the safety of being helped to make things more Pythonic, but at least I know that it will be fast. But that's a very good question. That's like the compromise for transpiler-based approaches.
In that case, I would like to give one more applause to our fine speaker. Thank you for speaking about this lovely topic.